In this problem, 2-point charges q and minus q are placed at a distance L, placed at a distance 2L from each other. Find the flux of the electric field across the circle of radius r. We will apply superposition principle here. That means we will calculate flux due to this charge q only. So there is that circle of radius r. So how much flux goes through it, it depends on how much solid angle is subtended at this point charge, right. So if you draw, it's like a cone, and the solid angle, this is it, right. This is the solid angle, the 3-dimensional angle omega. It depends on this plane angle theta. There is a certain relation. This is the easier way to solve the problem. If you know about solid angle, then else you have to do it by integrating the field. So that's a longer solution, right. So this solid angle omega is given by 2 pi into 1 minus cosine of theta. Now what's cosine of theta? I can write this 2 pi 1 minus cosine theta is, this distance is L, right. So 1 minus L by square root of this distance, right. So L by this distance is root over of r squared plus L square, right. So just due to this charge q only, the flux, the lines of force passing through the disc will be how much? How many lines of force will cross? So due to q, flux crossing the circle, is total flux q by epsilon naught divided by total solid angle in space 4 pi multiplied by the solid angle subtended 2 pi 1 minus L by root r square plus L square. That is it. This is the flux solely due to this charge q. Now when you have a charge minus q here, see, due to charge q, flux will live in this way. Due to minus q, the flux will cross the surface this way, right. So due to symmetry, you have to add. So net flux phi is twice of this q by epsilon naught. You have here half into 1 minus L by root L square plus r square, that's q by epsilon naught 1 minus L by root r square plus L square. This is by symmetry. The flux from the lines of force generating from charge q will cross the disc in this way, and if you have a charge minus q, due to that the lines of force will cross the circle in this way. So it's actually equal and symmetric. So you just multiply 2 with flux due to each charge.